In a daring announcement that could redefine our understanding of the cosmos, scientists have revealed the discovery of a celestial body unlike anything we've encountered before. This enigmatic planet, cloaked in mystery and wonder, has stunned the global scientific community. NASA, the renowned space agency long celebrated for its groundbreaking contributions to space exploration, has once again captured the world's imagination. What makes this planet so extraordinary isn't just its massive size or its unusual location in the solar system, it's the eerie light patterns it appears to emit. These strange, rhythmic glimmers have sparked a flurry of speculation. Are we witnessing a natural phenomenon unlike any we've catalogued before? Or, more intriguingly, could these luminous anomalies suggest something far more profound, the existence of life, or even a sign of intelligent design? To truly understand the implications of this cosmic revelation, we must take a step back and explore the technological and exploratory foundation that led us here. One of the most critical chapters in this journey begins with NASA's Dawn spacecraft, a mission that quietly revolutionized our understanding of two of the most overlooked members of our solar family, Vesta and Ceres. Launched in 2007, Dawn was a marvel of engineering, propelled not by traditional rockets but by ion propulsion, an innovative, whisper-quiet technology that allowed it to glide across the solar system with breathtaking efficiency. This allowed Dawn to become the first spacecraft ever to orbit two different extraterrestrial bodies in one mission, marking an extraordinary milestone in human space exploration. Dawn's mission started with Vesta, the second largest object in the asteroid belt between Mars and Jupiter. Over 14 months, the spacecraft conducted a meticulous survey of the massive asteroid. High-resolution images revealed Vesta's deeply pitted surface, ancient impact basins, and rugged mountainous terrain. It was like peering back in time at the building blocks of the solar system. Vesta, once considered a mere asteroid, proved to be a protoplanet, something that had nearly become a full-fledged planet before being interrupted by Jupiter's gravitational pull. The surface told a story of violent collisions, geological differentiation, and ancient activity. But as fascinating as Vesta was, the true heart of the mission, and its most tantalizing mystery, lay ahead. Next, Dawn journeyed toward Ceres, the largest object in the asteroid belt and classified as a dwarf planet. Its arrival in 2015 marked a historic achievement, the first time a spacecraft had orbited a dwarf planet. Ceres, first discovered in 1801 by Italian astronomer Giuseppe Piazzi, had long eluded detailed study. It had once been considered a planet, then reclassified as an asteroid, and finally elevated again to dwarf planet status in 2006. But beyond its shifting classification, Ceres was compelling for a more specific reason: something was shimmering on its surface. As dawn approached, cameras captured something astonishing. Bright, reflective patches dotted the landscape, unlike anything ever seen before in the asteroid belt. These weren't simple ice deposits. They stood out sharply against the otherwise dark and dusty surface of Ceres, especially in a large impact basin later named a Cater crater. The scientific community was electrified. What were these luminous spots? Early images from the Hubble Space Telescope had hinted at something unusual, but it was only with Dawn's arrival that their true nature began to come into focus. Initially, theories abounded. Could these be salt deposits? Exposed ice? Or even surface reflections from transient water activity? The most widely accepted explanation soon emerged. The bright spots were deposits of sodium carbonate, a kind of salt left behind by briny water that had once erupted from beneath the surface. This pointed to a geological process known as cryovolcanism, an icy version of volcanism where instead of molten rock, cold materials like water, ammonia, and other volatiles erupt from the crust. These were not violent eruptions but slow, quiet exhalations of planetary breath. This revelation was profound. It suggested that Ceres was not a dead world, but perhaps a geologically active one. That alone shattered long-held assumptions about small celestial bodies, which were generally thought to be cold, inert, and lifeless. But Ceres, with its deep subsurface brines, began to challenge that notion. Cryovolcanism, as subtle as it may appear, has powerful implications. It means that heat sources, possibly radioactive decay, still warm Ceres from within. It also means that beneath the rocky crust may lie reservoirs of liquid water, kept from freezing by a cocktail of ammonia and salts. Water is, of course, the holy grail of astrobiology. Wherever we find water on Earth, we find life. If liquid water has existed on Ceres for extended periods, especially if it still does, it becomes a compelling candidate in the search for extraterrestrial life. More intriguingly, the brines responsible for these bright spots could carry other dissolved materials, such as organic molecules. These compounds could provide not only nutrients for life but also clues to how life might originate in such alien environments. One of the most captivating regions on Ceres is the center of a crater, where the area known as Cerealia Facula gleams with an intensity unmatched anywhere else in the solar system. It is, quite literally, one of the brightest spots in the void. Observations from dawn revealed something even more peculiar: hazy clouds appearing and disappearing, rising in sync with Ceres' day-night cycle. Scientists interpreted this as water vapor sublimating, turning directly from ice to gas under the vacuum of space. This wasn't just evidence of past activity. It was a sign that Ceres might still be breathing today. And these bright spots aren't confined to one area. Dawn identified dozens of them scattered across the planet's surface, each with unique characteristics and histories. Some are fresh and crisp, indicating recent activity. Others are faded, worn down by time and the elements of space. This widespread distribution reinforces the idea that Ceres has experienced a long and dynamic geological history. The crust itself is thought to sit atop a layer of muddy brine, and possibly even a global subsurface ocean in its past, a structure more akin to icy moons like Europa or Enceladus than a typical asteroid. Adding to the mystery, Ceres hosts clay minerals enriched with ammonia. Ammonia is not native to the inner solar system, which implies that Ceres may not have formed where it currently resides. Instead, it might have originated in the colder outer reaches of the solar system and migrated inward. If this is true, Ceres becomes a cosmic migrant, carrying with it a recipe of ingredients from the edge of the solar system. Ingredients that might include precursors to life. The implications are staggering. If a small, seemingly insignificant world like Ceres can harbor water, brines, cryovolcanoes, and organic chemistry, then what other surprises lie in wait across the universe? Could these bright lights, sparkling like beacons in the void, be part of a natural process we are only beginning to understand? Or could they be something more? Something that challenges our perception of what is possible in the cold darkness between the stars. While the current consensus supports natural explanations, the regularity and precision of some observed light fluctuations have led a few outside-the-box thinkers to raise even more provocative questions. Could these patterns be signals? Could an intelligent civilization, now extinct or perhaps still active, have once used Ceres as a beacon or an outpost? Though there is no evidence yet to support such claims, the possibility adds a layer of awe to our observations. After all, every mystery begins with a question that challenges the obvious. As the Dawn mission came to its end in late 2018, the spacecraft was left in orbit around Ceres, silently circling the world it had revealed in unprecedented detail. Its batteries exhausted, its mission complete, it became a permanent satellite of the dwarf planet it had helped bring into focus. Yet, the data it sent back continues to provoke discussion, debate, and wonder. Researchers still sift through gigabytes of images and spectral readings, searching for answers, identifying new questions, and re-evaluating everything they thought they knew about small worlds. Today, Ceres stands as a sentinel of the unknown, an object that challenges our scientific assumptions and teases the imagination. The lights it displays, the chemistry it harbors, and the processes that shape it all point to a complex, active world with the potential to reveal secrets far beyond its size. And so, as we turn our gaze to the stars and launch new missions to even more distant realms, we do so with the understanding that sometimes the most profound truths come not from distant galaxies, but from quiet little planets, glowing softly in the darkness, asking us to look closer.